So binomial theorem for positive integral index. So we can have for negative index also, but for positive integral index. So the binomial theorem is defined like this, that for n belongs to natural numbers, all right, a plus b whole power n is equal to nc0 into a power n plus nc1 into a power n minus 1 times b plus nc2 a power n minus 2 times b square plus rth term, or um, the r plus first term, in fact the general term, ncr a power n minus r b power r, and the last term ncn b power n. So this is the general term. And so this is tr plus first term is ncr a power n minus r b power r. So we don't have mathematical induction for the syllabus, so but there is a proof by mathematical induction how this is so, but we will do a proof differently by logic. I'll explain to you. See, a plus b whole power n is nothing but a plus b into, I'm writing this as an explanation, not a proof. A plus b, a plus b into a plus b, so on, n terms. Okay, n terms basically. So there are n factors. Now, how does multiplication happen? Multiplication means from each term you have to choose, from the each factor you have to choose one term from here, one term from here, one term from here, one term from the nth factor, and then multiply them. That is how the combination works. So like for example, a plus b the whole square. A plus b is a plus b, no problem. A plus b whole power 1. A plus b the whole square is a plus b into a plus b. What do you get? A gets multiplied with a, you get a square. Then a gets multiplied, a from the first term gets multiplied with b from the second term, you get ab. Then b from the first gets multiplied with a with the second term, and b gets multiplied with b. This is how it happens. So here you get, because ab is equal to ba, you get a square plus b square plus 2ab. Now see, the each term will have the power equal to the index of the binomial expansion, a plus b whole square. So this is 2 here. So each term in the expansion will be of degree 2. So this is a square, this is b square, this is a power 1 and b power 1. But because these two are variables, so this is of order 2, or the collective cumulative index is 2, because 1 plus 1. Understood? So each term has the degree as 2. A plus b the whole cube. What happens is you are taking one term from the first factor, one term from the second factor, one term from the third factor. So a gets multiplied with a, gets multiplied with a, you get a cube. A gets multiplied with a and it gets multiplied with b, you will get a square b. Okay. So a multiplied with a multiplied with b over, then a b multiplied with a b multiplied with a, you again get a square b. Then a b multiplied with b, you get ab square. Correct? Then b gets multiplied with a and multiplied with a, again you get a square b times a square. Then b gets multiplied with a, gets multiplied with b, you get ab square, plus then b gets multiplied with b, then multiplied with a, you get b square a or ab square. And b gets multiplied with b and then gets multiplied with b, you get b cube. So this is a cube plus 3 a square b plus 3 ab square plus b cube. Now each term will be of degree 3. So this is a cube, b cube, here square term and degree 1 term, here degree 1 term and square term for b. So you get a plus b the whole cube. So now how to do it for a general term? For a general term, like there are n, right? Product of n factors. So the way the logic works is like this. Now I will select from each factor. I will count the selections of b's from from different factors. How many factors I will choose to select b? So let us start. The first term is I will not select any b. That means NC 0. If I have not selected any b, so from each factor I can select either a or b. So I am making this count for b. So I have not selected any b. That means from every factor I have selected a, right? So I get a into a into a into a into a. So that is, I'll get a power n. So from each factor I select a, and when I multiply I get a power n. And basically it is b power 0. I have not selected b. Next, in how many ways can I select from n factors? How many ways can I select one factor from which I select b? So from the n factors, I will select one factor, any one of the factors from where I'll select b. So I get NC1. So from one factor I am selecting b, from remaining factors I am selecting a. So when I multiply, I get a power n minus 1. But from one of the factors, I'm selecting b. So NC1 a power n minus 1 times b. Next, I want b square term next. Now. So from two factors, I will select b. So from NC2, from the n, I can select any two to get b. So two b's and remaining n minus 2 a's. So I get a power n minus 2 into b square. Are you understanding how we are doing?
Yes, sir.
So this is how we calculate. Now from the n factors, I select r factors, from where I select b's, and remaining n minus r, I'll select a's. So when I multiply, I get this. So continuing like this, last term I select all factors. From all the factors, I select b. So we get this. So this is the binomial theorem for positive integral index. So it is closely linked with selection. So NC0, NC1, NCN. So in general, this can also be written as, the expression can be written as uh, sigma NCR, or okay, NCR a power n minus r b power r ranging from 0 to n, r ranging from 0 to n. This sign sigma represents summation. So you substitute a value r, that will be one term, plus the next value of r. So when you substitute r equal to 0, you get nc0 a power n. That is the first term. R equal to 1, nc1 a power n minus 1 b. That's the second term. Next term, r equal to 2, nc2 a power n minus 2 b square. That will be the third term. So this is the representation. So now points to note. Now the coefficients NCR occurring in the binomial expansion, these are called as binomial expansions, a plus b whole power n. The coefficients NCR occurring in the binomial expansion are called as binomial coefficients. They are called as binomial coefficients. Now, second is the number of terms in the expansion of. Expansion of means binomial expansion of. A plus b whole power n is n plus 1. A binomial expansion has n plus 1 terms. The middle terms and the So if n is even, see, when n is even, you will get n plus 1 will be odd. So there will be odd number of terms. But when n is odd, then n plus 1 will be even. So we get even number of terms. Just okay. Just a second. The properties with this coefficients, we'll just derive that. But first we'll write this. Now, the middle term. If n is even, then there is only one middle term. There is only one middle term. That is n by 2. Actually, it will be term number n by 2 plus 1 will be the middle term. n by 2, a power n by 2, n minus n by 2. So it will be a power n by 2, b power n by 2. This is the middle term.
So why are we adding a +1 for t, sir?
Simple. Here, what did you get? The r plus 1 term, tr plus 1 will be ncr, a power n minus r, b power r.
Yes, sir, got it.
Because they are n plus 1 terms.
Correct, sir.
Yes, that is why. Now, if n is odd, then there are two middle terms because total number of terms will be even. There are two middle terms. One will be t. You will get basically, actually the middle terms, total number of terms will be n plus 1, which is even. So exact half. So for example, a plus b whole power 5. It will have 6 terms. First, second, third, fourth, fifth, sixth. Now n by 2 will be the third term. Okay. And actually n by 2 is 2.5. Kedar, mute yourself.
Sorry, sir.
Yeah. So these are the two middle terms. 5 by 2 is 2.5. So third term will be 5 plus 1 upon 2. That will be the third term. Then 5 plus 3 upon 2. Okay, plus 1, right? So 5 plus 3 upon 2. That will be the fourth term. So if n is odd, then there are two middle terms. What are they? N plus 1 by 2, which is nc n minus 1 by 2, because this is t r plus 1. So basically this is t n minus 1 by 2 plus 1. So you get nc n minus 1 by 2 a power n minus 1 by 2, that is n plus 1 by 2 into b power n minus 1 by 2, and t n plus 3 by 2, which is nc n plus 1 by 2 a power n minus 1 by 2 b power n plus 1 by 2. Okay, so these are the two middle terms. So I'm erasing this, or I'll just put it as an example. Okay, now there is a way. How do you do NCR? How do you calculate the coefficients? So there is something called as the Pascal's triangle. For that, say, understand this: a plus b whole power 0 is 1. A plus b whole power 1 is a plus b. A plus b the whole square is a square plus 2ab plus b square. A plus b the whole cube is a cube plus 3a square b plus 3ab square plus b cube. Then a plus b whole power 4 is a power 4 plus 4a square b, sorry, a cube b plus 6a square b square plus 4ab cube plus b power 4. So like this, it goes on. So now Pascal's triangle for coefficients. Pascal's triangle for binomial coefficients. Pascal's triangles for binomial coefficient. So you just observe, the first one is 1. Next, this is power 0, n equal to 0. Next, n equal to 1 means you will have two terms. Both starting term and end term will have coefficients 1. When n equal to 2, you will have three terms. Starting term will be 1, ending term will be 1. The middle term will be sum of the previous coefficients. Here. 1 plus 1. Okay, here it will just be 1 only along the ends, it will be 1. Now when n equal to 3, what will be the coefficients in the expansion? 1 at the beginning, 1 at the end, and then 1 plus 2, 3, 2 plus 1, 3. So this is 1, this is 1, no problem. This in between, 1 plus 1 from here, 2 from here, 1 plus 2, 3. Then 2 from here, 1 from here, 2 plus 1, 3. So this kind of a structure is called as the Pascal's triangle. Next, when n equal to 4. Now guess the coefficients. Coefficients 1, 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4, and then 1. 1, 4, 6, 4, 1. Okay, 1, 4, 6, 4, 1. Next one, n equal to 5. You get 1, 1 at the end, 1, 5, 4 plus 6, 10, 6 plus 4, 10, 4 plus 1, 5. So this is how a Pascal triangle works. 1 plus 4, 4 plus 6, 6 plus 4, 4 plus 1, and only 1. Just a second. I have a So this is called the Pascal's triangle. So these are your coefficients. You can see this is 1C1. This is 1 here, and this is 1C1, 1C1. I'll yeah. 1. Then we have 1C1, 1C1. Then 2, right? We have 2, sorry, 1C0, 1C1. Then 2C0, 2C1, 2C2. 2C0 is 1, 2C2 is 1, 2C1 is 2. So 1, 2, 1. Then we have 3C0, 3C1, 3C2, 3C3. 3C0, 3C1, 3C2, 3C3. So 1, 3, 3, 1. 3C1 is 3, 3C2 is 3. Then you have 4C0, 4C1, 4C2, 4C3, 4C4. And similarly, you have 5C0, 5C0, 5C1, 5C2, 5C3, 5C4, 5C5, and so on. Understood? So these are Pascal triangle coefficients. So we can calculate how to find the coefficients. This way also you can expand. If you didn't know NCR equal to n factorial by n minus r factorial into r factorial, then the way to find coefficients was using Pascal's triangle. But with the permutation combinations that we have learned, so we can straight away write NCR. We can find out NCR. So we don't have to go using Pascal's triangle. All right, we'll do some problems. Okay, let us do some examples. So expand one minus 2x whole power 5. So write the binomial expansion of 1 minus 2x whole power 5. So what will this be? Please tell me. 1 minus 2x whole power 5 will be 5c0 to 1 power 5 plus 5c1 into 1 power 4 times minus 2x whole power 1. Correct? Next, 5c2, the next term will be 5c2. Then 1 power 5 minus 2 is 3 and minus 2x power 2. So sum of the powers should be equal to the index 5 plus 5c3 into 1 power 5 minus 3 is 2 minus 2x whole power 3. Then 5c4, 1 power 5 minus 4 is 1 minus 2x whole power 4 plus 5c5, 1 power 0 and minus 2x whole power 5. So the binomial theorem, the expansion 5c0 is 1 power 1. 5c1 is 5 multiplied by minus 2x. 5c2 is 10. 5 into 4 by 1 into 2, 10 into 1 into 4x square. Then 5c3 is also 10 to 1 square into minus 2x the whole cube. That will be minus 8x cube plus Then 5C4 is 5 into 1 into this minus 2 whole power 4 is plus 2 power 4 is 16 x power 4 plus 5C5 is 1 into minus 2 power 5 is 32 x power 5. So the expansion will be 1 minus 10x plus 40x square minus 80x cube plus 80 x power 4 minus 32x power 5. So this is the binomial expansion. Next question. Find the binomial expansion of x by 3 plus 1 by x whole power 5. Will you do? Attempt. Write the expansion. I will see. Are you attempting?
Yes, sir.
Yeah. Five C 0 x by 3 whole power 5. 5C1 x by 3 whole power 4 into 1 by x plus 5C2 x by 3 whole cube 1 by x the whole square 5C3 1 by x whole power 5. So you get 5C0 is 1. So x power 5 by 3 power 5 is 243. 5 by 81 into x cube plus 10 by 27 x plus 10 by 9 into 1 by x plus 5 by 3 into 1 by x cube 1 by x power 5. So there's the binomial expansion. Okay, we can write this as 10 by 9x, and this term as 5 by 3x cube plus 1 by x power 5. So this is a binomial expansion. Next question. Using binomial theorem, evaluate the following. Okay, 96 whole cube the whole cube, 99 whole power 5. There is same 102 is also there, 101 whole power 4 is also there. We'll do this. Okay, I'll do this 101 whole power 4. So how to do this problems? So write 96 whole cube as 100 minus 4 whole cube. Then we get 3C0 into 100 whole cube plus 3C1 into 100 whole square into minus 4 plus 3C2 times 100 into minus 4 whole square plus 3C3 into minus 4 the whole cube. So this is 1, this is 100 cube. So 10 to the power 6. Leave it there for the moment. Then this is minus 3 into 4, 12. Plus 3C2 is again 3. 3 into 16 is 4800. Last term minus 3C3 is 1. 4 cube 16 4 64. So basically we have 1 0 0 0 0 0 0 10 power 6. So 10 power 6 and then 4800 and here you have 12 into 10 power 4. So minus 64. So 6400 and 12. Okay. So when we subtract this, we get the answer. We get 736 here. 88. So you get 884736. This is using binomial expansion. I'm just checking the answers. Eight eight 4736. That's right. Will you do the next one? 99 power 5. This is easier. Please do and give me an answer. 99 power 5, exactly the same way. You will write 99 as 100 minus 1 whole power 5. Please do the calculation. Yes. Have you solved? Five C 0, 100 power 5, 5 C 1, 5 C 2, 100 cube minus 1 square, 5 C 3, 100 square, 5 C 4. 5C5. So this is 10 power 10. And then this is 5 into minus 5 into 10 power 4. Then 5C2 is 10. This is already 10 power 6. So this becomes 10 power 7. No, this is 10 power 8. I'm sorry. This is 10 power 8. This is 10 power 7. Next term with a negative sign. 5C3 is 10. This is 10 power 4, 10 power 5. Plus 5C4 is 5. Then last one, 5C5 is 1. Now we'll just add the positive terms and then the negative terms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now 10 power 7. 7 zeros. 1, 2, 3, 4, 5, 6, 7. Then plus 500. Now 1, 2, 3, 4. And then you have 100. Okay. This is 1. These are addition of the positive terms and addition of the negative terms. Addition of the negative terms is 5 into 10 power 8. 2, 3, 4, 5, 6, 7, 8. 5 into 10 power 8. 5 into 10 power 5. So 1 into 10 power 5. And 1. So now we need to subtract. So this term we have to see this minus this. So 1 with 4 zeros. Then 1. So you get 499. And then 2 zeros. So you get 95099 00499. Okay. These are rough. Clear?
Yes, sir.
Next one, 101 whole power 4. That will be much easier. 101 whole power 4. This will be 100 plus 1 whole power 4. This is much easier. Please calculate. So it is 4C0 100 power 4 plus 4C1 100 cube plus 4C2 100 square into 1 square plus 4C3 100 plus 4C4. So 10 power 8, this is 4C1 is 4, so into 10 power 6, 6 zeros. 4C2 is 6, 4C3 is 4, 1. So this will be easier. So this is 1 followed by 6 zeros, 4 followed by 6 zeros. So you get 104 06 0401. This is the answer. Okay. So we'll stop here for this class. Tomorrow's class, we'll continue further problems on binomial theorem. Do you have any questions?
So can you please take those questions that are sent?
Okay, I'll see. I didn't see your questions. I'll just see. Okay, I'm stopping the recording for this class.